Okay, so this is math 2. We're going to do 93, 95, I'm sorry, 93, 94, and 105. All right, so for the first one, it says Ben thinks that the slope ratio for the triangle is 7 over 10. Clarissa thinks that the slope ratio is 7 or 10 over 7. So who is correct? They're actually both correct. The only thing that's different about them is how they're getting their numbers. So, for example, 7 over 10. He thinks, or Ben, I should say Ben, thinks it's 7 over 10. So this would be his change in y, and this would be his change in x. So if that's true, then Ben must be using the 35-degree angle to justify his 7 over 10. So it would look like, let's see, tangent of 35 degrees would be equal to 7 over 10. All right. Well, if it's Clarissa's turn, right, she thinks it's 10 over 7. So that would mean your change in y would be this one right here. There's your vertical, right, change in y. There's your horizontal, change in x. So that would mean that Clarissa is actually using the 55-degree angle to do her change in y and her change in x. So that would look like this. Tangent of 55 degrees would be equal to 10 over 7. All right, so technically they're both correct. It just depends on which angle they're actually using. All right, number 94. Use your observations from 92 to answer the following questions, which should be just fine. Thalia did not have a tool to help her determine the slope angle in the triangle at the right. However, she claims that the slope angle has to be more than 45. Do you agree? Yes or no? So the hint was an isosceles right triangle has a slope of 1 and a slope angle of 45. So if both sides were 6, for example, or if both sides were 4, then this would be easy to figure out. That would just be 1, because your slope triangle would be 1 over 1. But this slope triangle, whatever it is, the theta, okay, tangent of this, theta, would be 6 over 4, which would give you equal to, what's 6 divided by 4? 1.5, right? Well, 1.5 is obviously bigger than 1, so she is actually correct. It has to be more than 45 because our slope ratio, 6 over 4, is more than 1. If it was exactly 1, then it would be a 45-degree angle. If it was less than 1, if the slope ratio was less than 1, then it would have to be less than 45 degrees right over here. And that should actually answer your question for part B, too. She was trying to determine the slope ratio for the triangle, right? She says her answer is change in y, change in x. Whatever she got is 2.6, but that's 19 degrees, and so that can't be right. 19 degrees is less than 45 degrees, so your slope ratio has to be less than 1, if that makes sense. Okay, so the slope ratio, I'm just going to write this out. The slope ratio is, if the slope ratio, I should say, is 2.675, then the angle has to be more than 45 degrees because, well, your slope ratio for 45 degrees is 1. So if it's more than 1, then the angle has to be more than 45 degrees. Okay, now the last one, it says, without determining the actual value, what information do you know about x in the diagram at the right? Well, 76 degrees is more than 45 degrees, right? So that means when we do our slope triangle, our change in y over change in x, we get 9 over x, right? Well, if we do 9 over, let's say these were the same, right? So let's say we had like 9 over 9. Well, that would be a 1. So, and that can't happen because that's not a 45-degree angle. We know this is more than 45-degree angles. So that means we need a number, our slope ratio, when we figure it out, we need a number that's more than 1 when we take the slope ratio. Well, if you put a number less than 1 in here, right? Let's say, I'm sorry, not less than 1, less than, let's say we put a number like, I'm sorry, not less than, more than. Let's say we put like 18 or something like that. Look, like 9 over 18-ish. Let's say it was 9 over 18. Well, that's just like 1 over 2. That's less than 1. So that can't be because this is more than 45 degrees. So the number here can't be more than 9. Otherwise, we have an issue. It's going to end up being a fraction. I mean, it's going to end up being a number less than 1. So that can't be happening. Or even if we did like 9 over 10, right? That's still a number that's less than 1. So that we can't do anything more than 9 in this area here, which means we have to actually have a number less than 9. So whatever happens here, we can try it like, let's try 8, right? 9 over 8. Well, 9 divided by 8 is like 1.125. So that kind of works. I mean, it's not a very big number. It's not much bigger than 1. But you don't know what it is. All you know is that the value of x has to be less than 9. And that's what I'm going to write up here. The value of x has to be less than 1. Otherwise, it's not going to work out. Okay. I think that's it. Oh, and then 105, sorry. All right, these ones, it says, usually calculate the missing side length for each triangle. Use the tangent button on your calculator to help. So we're going to set this up using a tangent button. So it's 8 degrees, right? Change in y. This is my change in y. This is my change in x. Okay. We're going to use this using the calculator. So we're not going to use the trig ratio table for this or anything like that. So we're going to set this up. So tangent of 8 degrees is equal to change in y over change in x. So t over 82. Okay. So that's your first step. There's your setup. Now, if you go on the calculator, then you type in tangent. And you put, first of all, make sure you're in degrees because it should say DEG down at the bottom, right? And then you're going to type in 8 because tangent of 8 degrees. And it gives you a decimal 0.1405. So I'm going to round to 4 decimal places, 1405. 0.1405 equals t over 82. Okay, so now we need to solve this. Right? So this one times that one. And you should get, and then t times 1. So t times 1 is just t, right? Or 1t. And then this times this should give you 11.5243. Okay? So there's your value for t. All right? B is kind of the same thing. It's just pretty much a different angle. There's not really much to it. So this is going to be your change in y. This is going to be your change in x. So let's see. We have change in y. Okay, so tangent. Let's see what we have. Tangent of 75 degrees is equal to change in y over change in x, so 12 over p. All right, so tangent of 75 degrees should be, let's see, tangent of 75 degrees, 3.7321. 3.7321. 3.7321 equals 12 over p. All right, so we're going to put a 1 under here. 12 times 1 is just 12. So this times p is just 3.7321p. And I'm going to divide both sides by 3.7321, 3.7321, and 12 divided by 3.7321 is 3.2153. 154 actually, because I'm running 4 decimal places. Okay. All right. So that's the value of P. So the side length here is 3.2154. All right, and then, so here you can pretty much decide how you want to turn this. So I'm going to, if you keep the 68 degrees, which is fine, I'm actually going to find this angle first down here. So my angle here is going to be, so 68, oh, that's 90 minus 68, so that's just 22. Okay, all right. Okay, so now I have 22 degrees, right? So 22 degrees, this would be my change in y, and this would be my change in x. All right, so we have tangent of 22 degrees equals 60 over b. Okay, and you can pretty much solve it from there. So don't forget, convert it to a decimal first, because it's pretty much the same setup as b, and then put it over 1, cross multiply if you need to, and then divide by the number in front of the variable, and you should end up with a value for b. All right. I think that's it. Yep, that's it. If you have any questions, you can see me on your own.